Good morning. I, Mrs. V. A. Yavle, Assistant Professor in Department of Electrical Engineering, AISSMS, Institute of Information Technology, would be discussing today a numerical on leakage reactance. So let's see a numerical on leakage reactance. A 600 kVA, 6600 by 400 volt, 50 Hz, 3-phase core type transformer has width of the LV winding 3 centimeters, width of HV winding 3 centimeters, width of the duct between LV and HV 2 centimeters, height of HV and LV windings 40 centimeters, length of mean turn 1.5 meters, number of HV winding turns 220. Estimate the leakage reactance of transformer referred to the HV side. So as we had discussed earlier, before starting with the numerical, we have to first identify the various parameters which are given in the numerical, right? So when we see width of the LV winding, you can see the LV winding is 400 volts, which is the secondary voltage. So the first parameter, width of LV winding, will be BS is equal to 3 centimeters. You have to convert it to meters, so it will be 0.03 meters. Now, width of the HV winding, which is on the primary side, 6600. So the second parameter is BP is equal to 3 centimeters again, which is 0.03 meters. Width of duct between LV and HV winding, the symbol is small a, which is again 2 centimeters, so which comes out to be 0.02 meters. Height of HV and LV windings is denoted by capital L subscript C, which is 40 centimeters, so which will be 0.4 meters. Next, length of mean turn is LMT, which is 1.5 meters. There is no need to convert it because it is already in the standard unit. And number of HV winding turns. You can see the HV winding turns 6600, which is the primary winding. So we can symbolize this by writing TP is equal to 6600, right? So once we have converted the respective word numerical into their following parameters, we can proceed with the numerical. So we are supposed to find the leakage reactance of the transformer referred to the HV side, that is to the primary side. So the formula for it is XP is equal to 2 pi F mu naught TP square LMT upon LC A plus BP plus BS upon 3. You have to please remember that this divided by 3 is only with BP plus BS. Now let's check whether all the values are available with us. So we know the frequency, mu naught is a constant, number of primary turns are given to us, LMT, LC is also available, small a, that is width of the duct, is given, width of primary winding, width of secondary winding is known. So there is no confusion in this. Once you have converted the given data, you can easily put the values and we can calculate it. So it will be 2 pi, frequency is 50 Hertz, mu naught we already know is 4 pi into 10 raised to power minus 7. Number of primary turns is 6600. LMT is 1.5 meter. LC is 0.4 meters. A is 0.02 plus BP is 0.03 plus BS is also 0.03 upon 3. Yes, so yeah, by mistake I have not done the square here, students. It is TP square, so it has to be 6600 whole square. So now it's just a matter of you have to put the values and you also are supposed to square it. So when you square this, sorry students, I have taken the number of turns, I think wrong. The HV winding turns is 220. Please replace it. It is not 6600. It is 220. right? So this will become 220. Please correct it. So it is 220 the whole square. So just put the values in your calculator and you will get the answer as xp is equal to 2.866 ohms. So once you have understood how to convert the given word problem into the following parameters and know the formula, it is very simple to calculate the leakage reactance. So the question was calculation of the leakage reactance referred to the primary side. So hope you all would have understood this. Thank you.